module. You will learn about the factors that favor the formation of ionic bond or electrovalent bond. On the basis of Cosell and Lewis approach towards chemical bond, we can explain the factors that affect the formation of ionic bond. The formation of ionic bonds depends upon the following three key factors. First, the ease of formation of a cation. Second, the ease of formation of an anion. And finally, the arrangements of the positive and the negative ions in the ionic solid. Let us understand this by considering the formation of sodium chloride. In the formation of sodium chloride, sodium loses one electron and attains the configuration of its nearest noble gas, neon. The amount of energy required for the ionization of a neutral atom, which is sodium atom in this example, is called ionization enthalpy. It is always endothermic. Similarly, chlorine accepts one electron to attain the configuration of its nearest noble gas, argon. The amount of energy liberated for the gain of electrons by chlorine atom is said to be electron gain enthalpy. It is represented as delta EGH. It is defined as the enthalpy change when a gaseous atom gains an electron. Note that the electron gain enthalpy may be exothermic or endothermic. Thus, sodium forms a positive ion, that is a cation, whereas chlorine forms a negative ion, that is an anion. Due to the strong electrostatic forces of attraction between these oppositely charged ions, they are held together to form sodium chloride. Now let us understand how ionization enthalpy and electron gain enthalpy affect the formation of an ionic bond. The ease of formation of a cation depends on the magnitude of the ionization enthalpy. Lower the ionization enthalpy, easier the removal of electron, and hence greater is the ease of formation of cation. Similarly, the ease of formation of an anion depends on the magnitude of the electron gain enthalpy. More negative is the electron gain enthalpy, greater is the ease of formation of the anion. Hence, we can conclude that lower the ionization enthalpy and higher the negative value of electron gain enthalpy, greater is the ease of formation of an ionic bond. The resultant ionic compound consists of regular and orderly arrangement of oppositely charged ions in three-dimensional region, held by strong electrostatic forces of attraction. This means that each cation is surrounded by a fixed number of anions and each anion is surrounded by a fixed number of cations. In a crystal of sodium chloride, each sodium ion is surrounded by 6 chloride ions, and each chloride ion is surrounded by 6 sodium ions as shown here. The difference in the crystal structures of different ionic compounds is attributed to the size of ions, their packing arrangements, and other factors. Finally, a requisite number of oppositely charged ions combine to form a crystal lattice. This process involves the liberation of energy. The higher the amount of the energy released, the greater the stability of the ionic compound. The stability of an ionic compound can be predicted by calculating the total enthalpy change in the process. In ionic solids, the sum of the electron gain enthalpy and the ionization enthalpy may be positive. But still, the crystal structure is stabilized due to the energy released during the formation of the crystal lattice. For example, in the gaseous state, the ionization enthalpy for the formation of Na+ from sodium is plus 495.8 kJ per mole, while the electron gain enthalpy for the formation of a chlorine ion is minus 348.7 kJ per mole. The sum of the two, which is 147.1 kJ per mole, is positive. But this is compensated by the energy released during the formation of the crystal lattice of sodium chloride, which is minus 788 kJ per mole. The overall energy released is the sum of 495.8 minus 348.7 and minus 788, which results in minus 640.9 kJ per mole. Since energy is released in the process, it makes the crystal lattice more stable. Thus, the magnitude of energy released during the formation of crystal lattice, called lattice enthalpy, provides a measure for determination of the stability of the ionic compound. Thus, lattice enthalpy plays a vital role in the formation of ionic compounds. Lattice enthalpy of an ionic solid is defined as the energy required to completely separate 1 mole of a solid ionic compound into gaseous constituent ions. For example, the lattice enthalpy of sodium chloride is 788 kJ per mole. This means that the energy required for the separation of 1 mole of solid sodium chloride into 1 mole of gaseous sodium ion and 1 mole of chloride ion is 788 kJ per mole. You have now reached the end of this module. In this module, you learned that the formation of ionic bonds depends upon the following 3 key factors. First, the ease of formation of a cation. Second, the ease of formation of an anion. And finally, the arrangement of the positive and negative ions in the ionic solid. Lower the ionization enthalpy and higher the negative value of electron gain enthalpy, greater is the ease of formation of a cation and an ion. Hence, greater is the ease of formation of an ionic bond. The magnitude of energy released during the formation of crystal lattice, called lattice enthalpy, provides a measure for determination of the stability of the ionic compound.